caught all of it. Okay. Here we go. Okay, so for our next example, let's say Jack and Roy are skating. Whoever skates the farthest along a straight line after 8 seconds wins. Okay, so Jack skates at a velocity of f of t equals 11 plus t feet per second. And Roy skates at a velocity of g of t equals 17 minus sine of pi times t over 3 feet per second. Who wins the race? Okay. So really all we have to do is find the displacement for both of them and see who went the furthest in 8 seconds. Okay, so for Jack,
is that pi of t?
Yep, pi times t. Okay, so for Jack, after 8 seconds, so we have the integral from t equals 0 to 8. And for Jack, that's his velocity function. So 11 plus t with respect to t. Okay, so now we find his net displacement. Okay, so the integral of 11 is 11t plus the integral of t is t squared over 2. And that's from 0 to 8. Okay, so if we plug in our 8, move that over a little bit, we have 11 times 8. Clean that 11 up a little bit. Plus 8 squared over 2 minus, now we plug in our 0, which is just 11 times 0 plus 0 squared over 2. Okay, well, that one just disappears since it's just 0 plus 0. Okay, so you have 88 plus 64 divided by 2 is 32, which is 120 feet. Okay, so Jack went 120 feet in 8 seconds. Okay. So now we do the same thing for Roy and just see who went further. Okay. So for Roy, same thing from 0 to 8 seconds. We kind of separate that a little bit. But his velocity function is 17 minus sine of pi times t over 3. Okay, which is equal to 17, the antiderivative of 17 is 17 times t. Kind of strip that 1. Minus, you have cosine. Oh, actually, let me move that. Yep, it would be a positive cosine. Nope, actually. Yep, positive cosine. I'm mixing up my derivatives for a second there. So you have cosine, which becomes negative, so that becomes positive. Yeah. I don't know. I had to make sure I'm doing my own little of pi times t over 3. And I don't know why they threw this problem in, because we don't cover u substitution for trig yet. So this actually becomes times the derivative of this. Well, I guess you could say divided by the derivative of that, which is, instead of pi over 3, becomes 3 over pi. And that's what we're covering u substitution. Like I said, I'm not really sure why they put this particular problem in here.
Is that we're just basically taking the antiderivative of the inside at that point?
Yep, so you take the the integral of the whole thing, then you take the derivative of what's inside.
Oh, it is.
You divide it by the derivative of what's inside. So it's, like I said, it's kind of one of those, you'd have to see the steps. And we're going to cover it a little bit today, but just not for the integral. We won't get to the trig substitution until next class. But we're going to do the regular u substitution today. So hopefully you'll see why it kind of flips. All right, so and that's from 0 to 8. Okay, so if we plug in our 8, we have 17 times 8 plus 3 over pi times cosine of 8 pi over 3. Minus, plug in our 0, and that 0 is looking a little bit rough. There we go. So you have 17 times 0 plus 3 over pi cosine 0, or 0 pi over, not t, 3. Yeah. Okay.
Cosine of 0 is 1.
Yep, cosine of 0 is 1.
Oh, but then, yeah, the cosine of 0 is 1, and then you multiply that by 3 over pi.
Yep. That's just 3 over pi.
Oh, okay.
Yep. So you have 17 times 8, which is 136. You have, actually, with cosine of 8 pi over 3, you can just plug that into your calculator. So you have 3 over pi times cosine of 8 pi over 3. And that one, cosine of 0 is 1. So that should be, oh, that's minus. Why do I have that as plus? For some reason I have that as plus. I don't know why, but it should be minus. You should get 134.6. Let me make sure. Yeah. So actually, yep, that should be minus 3 over pi. Yep, don't know why I put that there. Let me change that now. I think that was just an error on my part. 134.6 feet per second. Well, feet in 8 seconds. Yep. All right. So any questions on that one?
So you just plug all that in a calculator?
Yep, once you get to right here, you can just plug it into your calculator. No use trying to go back and figure out
What
8 pi over 3 and which quadrant it's in and all that other stuff. Just at this point, I'm assuming you know it.
On the exam? Like on the final exam?
Oh, on the final, then that's a whole different story. You'd actually have to know it if a question like that pops up.
Okay.
Yeah, so that's a whole different issue. All right, so any questions on that one? All right.
So the answer is Roy wins.
Yep, Roy wins, yep. Actually, I should have put that down. Roy wins.
So the velocity is beforehand, and then the net velocity is when we take the integral of it?
Yep, so that just gives you the position at those particular times. Once you get the integral of the velocity, then you just have a position function.
Okay.
So once you have your position function, now you're just finding the distance between the two of the position function. Okay, so now if we have a car that accelerates at a rate of a of t equals 1 over 10 t squared minus t meters per second. Determine how much the velocity increases between 5 and 15 seconds after accelerating, or after first accelerating. All right, so this one's just a little bit different. Instead of giving us the velocity, they're giving us the acceleration. And they want us to find the change in velocity. Okay, so if we remember your s of t is the position function. Our s prime of t, which is our v of t, that's our velocity. And our second derivative, which is the first derivative of the velocity, is our acceleration function. Okay, so they gave us the acceleration.
So you just find the antiderivative.
Yep, so the integral of our acceleration is just really the integral of our velocity function prime. So the integral of our velocity function, or of the velocity function prime, is just our velocity function. So that would give us the change in velocity. Of course, if we had it from A to B, it would be V of A minus V of B minus V of A. Okay, so really all we have to do, since we're going from 5 to 15 seconds, of our acceleration function, which is 1 over 10 t squared minus t, with respect to t. And then we just integrate both terms. So that's equal to 1 over 10, and that's t squared divided by 2. Or if you want to make it t squared over 20, you can. Oh, t to the third over 3. I'm looking ahead. T to the third over 3, and that becomes t squared over 2. Move that up a little bit. T squared over 2, and we're going from 5 to 15. Okay, so we plug in our 15 and go ahead and move that over a little bit. So we have 1 over 10, and if you want, like I say, you can go ahead and make that 1 over 30. Times 15 to the third power minus 15 squared over 2 minus, now we plug in our 5, 1 over 30 times 5 to the third power minus 5 squared over 2. Okay, so that actually gives us 3375 over 30 minus 225 over 2. If we distribute that, we'd end up with 225 over 30. 125 over 30, sorry. Plus 25 over 2. So once you plug all that in, you end up with, skipping all those extra steps, 25 over, well, 50 over 6, which is 25 over 3. Oh, sorry about that. Move that up a little bit. Which, once you plug that in, it's about 8.3. So it increases about 8.3 meters per second. Meters per second between 5 and 15 seconds after accelerating. Let's bring that up some more. Yes.
You don't need to do the long process of 15 to 5 equals the integral of 15 to 0 minus the integral of 5 to 0. I think I'm overdoing it.
Oh, you mean you distributed the interval to both of those? Or you didn't do that? Is that what you were saying?
I did it so that the integral was, it was going to be the integral of that function between 15 and 0 minus the integral of that function between 5 and 0. I would think that would give us...
You remember, A is always less than B. So
Right.
you couldn't really go from 15 to 0. You can go from 0 to 15.
0 to 15
Yep.
and then 0 to 5.
You didn't have to do that one. You could have went right from 5 to 15.
That's only if they necessarily give you a piecewise function or...
Oh yeah, if they give you a piecewise, then that's when you separate it like that. But if they give you just one velocity function or one acceleration function, then you just have to go straight through.
Right. And all the way back in sigma, like you would have to do that too?
You mean for this one? Or just
sigma equations in general, I think.
Oh, for the sigma, you would have to, if I'm thinking correctly, you'd go from, let's say, 0 to whatever value, but then you go up one more when you add them together.
Oh, okay.
Yep, so that's the difference between these two.
Yeah, but... Okay.
These, you just start right at the same one.
Oh, okay.
Yeah. I had to think back a little bit. All right, any other questions on this one? All right. Okay. Do one more of these, and then we'll move up to the even and odd integrals. Okay, so the engine in a car started at t equals 0, and it consumes gasoline. Uh-oh. At a rate of 2t squared plus 2t plus 1 gallons per hour. How much gas is consumed in the first hour? Clean that S up a little bit. Okay, so you know your rate of change is 2t squared plus 2t plus 1. So you know that's your velocity function. So you could put v of t, f of t, either one wouldn't really matter. Okay, so you're going for the first hour. So you're going from t equals 0 to t equals 1. So from t equals 0 to t equals 1, we have the integral from 0 to 1 of our velocity function. Okay, which is the integral from 0 to 1 of 2t squared plus 2t plus 1. Okay, so now we just go ahead and integrate each term. So the first term becomes t to the third over 3. So you have 2 times t to the third over 3 plus 2. This becomes t squared over 2. And the integral of 1 is just t. And you go from 0 to 1. Okay, so go ahead and plug in our 1. We can just make that 2 over 3 times 1 to the third plus 2. That actually cancels out, so that disappears and just becomes 1 squared plus 1 minus, now we plug in our 0. So you have 2/3 times 0 to the third, which you could have just left at 0, plus 0 squared plus 0, and all three of those just disappear. Okay, so you have 2/3 plus 1 squared plus 1, which is 2/3 plus 3 over 3 plus 3 over 3, which is 8 over 3, which is 2 2/3 gallons. Clean up that 3 a little bit. Gallons of gas. Okay, so in the first hour, 2 2/3 gallons. All right, so any questions on this one?
What would you be saying if you just substituted in 1 for v of t? What would that be saying?
That would give you a velocity at 1 second.
So that's just saying, would that be how much gas we could, no, that's not how much
Yep, that's
gas
just,
we could
oh,
consume in 1
that's right,
second.
this is rate of change. That's just how much gas was used at 1 second. So I'm thinking of how much gas was, the rate that gas was being used at that second. I'm thinking velocity was the car moving. Yep, so your velocity, the rate of that the gas is being used, if you plugged in 1, they were saying, okay, at 1 second, it was using gas at this rate. Then let's say at 5 seconds, maybe they were going faster or slower. Say, okay, they were using gas at this rate at 5 seconds. So if you just plugged it right in, that's what it would give you.
Oh, okay, I see. Because this is a additive quantity, like, I'm trying to think of it like it's going up to that velocity, if that makes sense. Or like going up to that, not acceleration or whatnot, but.
So I think I know what you're talking about. You're saying that because it's always just going to be,
Yeah,
it's
slowly
increasing,
building,
that
yeah, slowly increasing.
the acceleration is always going to be, because the slope is always positive, it's always going to be accelerating.
Yeah, okay.
Yeah. Okay. Any other questions on this one? All right. I think we'll make it. Okay. So integrating even and odd functions. Okay, so if you remember, an even function which is symmetric across the y-axis can be found if f of negative x equals f of x. And an odd function which is symmetric across the origin can be found if f of negative x equals negative f of x. Okay. Now if a function is even, kind of separate that. If a function is even, then the integral from negative a to a of f of x with respect to x is equal to 2 times the integral from 0 to a of f of x with respect to x. Okay. So let's say if we have, just to kind of visualize it, let's say we have a graph, our y, this is our x, and our graph kind of looks like this. It's kind of a mirror image across the y-axis. Okay. So we know it's an even function. Okay. Let's say this is our negative a, and this is our a. So if we wanted to find the area across this whole thing, it's a mirror image on both sides. So we can just go from 0 to a and multiply by 2. Okay. Now if a function is odd, then the integral from negative a to a of f of x with respect to x is actually equal to 0.